Right, now that we know about orbitals and whatnot, we're going to next touch on electron configurations, which are the arrangement of electrons in an atom. And the great thing about electron configurations is that as long as we know how to read the periodic table, we're provided with all of this information. So for example, here we have carbon. Right here on the periodic table, it has 6 protons and it's in its neutral state. It has 6 electrons. So we want to know about where those electrons are because that'll tell us about the reactivity about carbon. So carbon's electron configuration is 1s2, 2s2, 2p6, right? So let's figure out what all this stuff means. The numbers, the 1, 2, and 3 are our principal quantum number, and so that's the overall energy of the orbital. The letters, the S and the P, tell us about the shape of the orbital. That's our M sub L values. And then finally, the superscripts, the 2, whoops, this should have been a 2 as well, my bad, 2p2, tell us the number of electrons. In those orbitals. And we'll take a look at an example of how to write out electron configurations in the next video. But the cool thing about this is that the periodic table has all of this info. So there's not too much memorization we have to do. We just have to understand how to read the periodic table. And so here's just a different version of the periodic table that's kind of meant more to illustrate the electron configurations. So we can see over here on the left, we've got our n values. Right, n equals 1, 2, 3, 4, 5, 6, 7. Right, so there's our n values. Over here in blue, we've got the s block. Right, that's our L equals 0. Remember that there's 2 electrons in each orbital. That's why there's 1, 2 columns there. Don't forget helium is also part of the s block, even though it's all the way over there. Over to the right in this pinkish color, we've got our p block. Right, so you've got your 2p, 3p, 4p, 5p. Again, the number in front is the n value. Remember that when we're in the p block, our L is equal to 1, which means our M sub L value can be equal to -1, 0, or 1, right? So that represents our 3 different p orbitals. And remember, there's 2 electrons per orbital. So if we have 3 orbitals, we have 6 electrons, right? And that's why there's 1, 2, 3, 4, 5, 6 columns in the p block. And so on and so forth, right? This is the D block. Right here, your L is equal to 2. Your M sub L can go all the way from -2 to +2. If you count how many there are, that's 5 orbitals. 2 electrons per orbital, that's 10 electrons. And if you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the same thing for the F block. Right here, your L is equal to 3, so your M sub L can be -3, -2, -1, 0, 1, 2, 3. That's 7 orbitals, which corresponds to 14 electrons, and there are indeed 14 columns here. So overall, electron configuration is not too bad. We're going to practice how to do them. All you're really doing is reading the periodic table left to right, line by line. There are a few quirks that you want to pay attention to. So we'll go over those quirks in greater detail throughout the videos. But just one big one to keep your eye on. Note how this is 4s and 4p. This is only 3d. We'll check on that a little bit later.